In this video, we focus on the thermal envelope of buildings. The thermal envelope is not just a barrier between the interior and the exterior. It is a complex system that serves multiple functions. These include temperature regulation through insulation, controlling airflow through airtightness, and mitigating solar heat gain via window placements and shading. Why timber? Timber's unique properties make it exceptionally well suited for constructing effective thermal envelopes. It allows for substantial thermal insulation without requiring excessively thick walls. Timber is an organic, low thermal conductivity material. It's essentially full of tiny pockets of air, making it a natural insulator. Before diving into the various layers involved in roof construction, let's first examine an exploded diagram of a typical timber frame envelope. This will help you understand how each component, inner lining, load-bearing structure, thermal insulation, insulation protection, cladding substructure, exterior cladding, and surface treatment plays a critical role. Like the timber frame envelope, each layer in a CLT component serves a specific purpose. Take a moment to examine this exploded diagram, focusing on how the layers interact and contribute to the thermal envelope's performance. The U value measures the thermal conductivity of materials and is a critical metric in achieving energy efficiency. This is expressed in watts per square meter per degree Kelvin. Lower U values signify better insulation properties. It's essential to scrutinize the U values when choosing materials for your thermal envelope. Ubaqus, for example, is more than just a calculator. It's an essential tool for architects and builders. By calculating factors like U values, moisture levels, and thermal bridges, Ubaqus helps optimize thermal performance down to the smallest details. Let's look at roof construction. Once again, each layer has a purpose. Roof coverings offer the first line of protection against weather, while secondary waterproofing ensures no moisture penetrates. Thermal insulation regulates temperature, and a vapor barrier prevents condensation inside the roof structure. Together, they create a well-orchestrated living space that is both functional and protective. We've discussed wall and roof structures. Now let's look at floors and ceilings, which also play an essential role in thermal and acoustic comfort. The choice between beam, box, CLT and DLT ceilings can significantly affect both thermal and acoustic performance. We've discussed wall and roof structures. Now let's look at floors and ceilings, which also play an essential role in thermal and acoustic comfort. The choice between beam, box, CLT and DLT ceilings can significantly affect both thermal and acoustic performance. Similarly, walls in timber construction have multiple layers. Thermal insulation is sandwiched between an external cladding and an internal lining. Between these layers, a vapor barrier and an airtight membrane control moisture and airflow. Crucial for both the lifespan of the building materials and the comfort of the inhabitants. External walls can be designed in multiple ways, each with its benefits and challenges. Here we look at two different compositions: solid timber structure and timber panel structure. Understanding their different layers and properties will give you the flexibility to select the best option depending on your project's needs. Let's now look at two other fascinating possible envelopes in wooden construction, specifically the Holzbohr envelopes produced by Küng Holzbau. On your left, you'll see the pure solid wood variant of the Holzbohr envelope. This type remains visible both inside and outside, providing a tactile and visual connection to nature. On the right, you'll notice a ventilated wall construction with wooden sheathing, another brilliant offering in the Holzboer range. Holzboer aims for simplicity. No metal, glue or chemicals. Just wood, mainly regional silver firs and spruces. These envelopes perform well in thermal insulation, heat storage and sound and fire protection. Humidity in a Holzboer house typically stays at around 45% all year. The walls are designed to breathe, minimizing moisture issues. Structurally, Holzboer uses lattice girders for rigidity. This allows for some architectural flexibility, even in multi-story buildings. The construction process is also relatively quick. Let's pivot for a moment to real-world applications. We're going to talk about an innovative project located in Trondheim, Norway, Dikehaugen 12, also known as Sponhuset, designed by architect August Schmidt. This project brilliantly navigates building regulations while offering a unique approach to thermal envelopes. The design separates the exterior skin from the insulated interior wall with an open air space of about 1.4 meters. This gap serves as a multi-purpose space, ranging from parking to storage on the ground floor. On the upper floor, deep window niches emerge from this space, extending the warm living areas without affecting floor space calculations. Looking at the floor plans and cross-sections, notice how the thermal insulating envelope is clearly demarcated in yellow. This leaves the buffer zone visible. The walls of the living space are filled with 35 centimeters of paper insulation. The U values achieved are impressive: 0.13 for walls, 0.11 for the roof, and 0.13 for the floor. The facade is shingle-clad and unpainted, designed for low maintenance. It acts as an outer shelter climate shield, adding another layer of weatherproofing and insulation. Let's zoom in and examine a groundbreaking project called Einfach bauen, building simply in English. This project tackles the intricate challenges of building comfort and energy efficiency by simplifying construction methods. It serves as a prime example of how the architecture itself can be optimized to require minimal technology for maintaining a comfortable indoor climate. Contrast is a great teacher. Here you see two facade details. One is a standard construction with multiple layers. The other employs the Einfach bauen principle. Fewer layers, but high-quality materials. Notice how simplification can actually improve thermal efficiency. Einfach bauen used 3 types of materials for its 3 research houses: solid wood, lightweight concrete, and masonry. Observe the materials' interaction with the environment. The facade is not just a design element, it's a functional monolithic unit that contributes to the thermal envelope. This slide allows you to see the facade details. Even though they look simple, they are designed to minimize thermal bridges and maximize thermal mass. Simplicity here is deceptive. It's also highly functional. The project adopted a layered approach focusing on 4 main elements, as highlighted here in the floor plans: the shell, the finishing, the fixtures, and the envelope. These provide a clear separation and therefore flexibility between elements, contributing to the circular design of the building. The interior of the solid wood house provides a sense of how it all comes together. The insulation is integrated inside the timber walls, and you'll also note a focus on passive ventilation through pivoting windows. The special room height with the high windows flood the apartments with sufficient daylight. Let's shift our focus to a real-world example to understand these concepts better. The Kung office building in Switzerland, designed by Seiler Linhart Architekten, serves as an excellent case study. From the outside, the building is a neatly joined wooden shell, featuring hanging parts made from oak and a facade clad with roughly sawn spruce boarding. This combination isn't just for aesthetics. It has a thermal role too. The walls are 40 centimeters thick and composed of two pure wood elements separated by a layer of wind paper, providing excellent insulation. Let's examine another real-world example to see these principles in action. Our case study focuses on the Cradle, an office building in Düsseldorf's Media Harbor district. Designed by HPP Architekten, it is the city's first timber hybrid construction. In collaboration with Knippers Helbig and Transsolar, HPP Architekten developed an integral facade that serves as both a supporting structure and a shading mechanism. Its design varies based on orientation to optimize for sun protection. The facade's rhombic structure is designed parametrically in 3D, aligning with multiple needs like light, shade, and visual aesthetics. Importantly, the depth and orientation of the facade construction depend on a specific support grid, known as V-supports, as well as support depth and angle. An extraordinary aspect of the Cradle's construction process was its use of prefabricated V-elements. These were carefully lifted into place on site using cranes, further speeding up the building timeline. Another unique feature of these V-elements is their joints, specifically designed for easy dismantling. This aligns with the building's cradle-to-cradle sustainability philosophy, emphasizing not just a building's life, but also its end-of-life considerations. By using joints that can be taken apart, the building provides future flexibility for modification or deconstruction. As we wrap up, let's take a moment to revisit what we've learned. We delved into what a thermal envelope is and why it's the unsung hero in building design. We explored how timber with its unique properties can make your thermal envelope not just effective, but also sustainable. You've also gained insights into metrics like U-value and got acquainted with tools like Ubaqus to make your designs even more precise. Remember, designing a robust thermal envelope is not just an architectural requirement. It's a commitment to long-term comfort and sustainability.